Hello people of the internet and welcome to my quick guide for finding the nth term of any quadratic sequence. This is perfect for GCSE Maths. So, this is an example of a quadratic sequence. How do we know it's quadratic? Well, let's start by finding the difference between these values. We can say that this is 3, 5, 7 and 9. You'll notice that these are not the same. So let's find the difference between these values. This is known as the second difference. This should be the same for all quadratic sequences. In this case, it is 2. Now, some rules for finding the nth term for quadratics. 2a is your second difference, in this case the orange 2. 3a plus b is the first difference, in this case the green 3, and a plus b plus c is your first term, in this case the purple 4. All nth terms for quadratic sequences are written in the form an squared plus bn plus c, which means you need to find a, b and c. So, to find a, we know that 2a is our second difference, in this case 2, therefore a simply equals 1. To find b, we need to know that 3a plus b is 3, as it is our first difference, therefore 3 times 1, as a is 1, plus b equals 3. Therefore, b equals 0. And now finally, a plus b plus c is our first term, in this case 4. Therefore, 1 plus 0 plus c is 4. Therefore, c equals 3. We now need to write this in the form an squared plus bn plus c. We know that a is 1. Therefore, 1 times n squared is simply left as n squared. We do not need to write 1 in there. Now we're adding 0n. Normally, we would not put this part of the equation in, and we would just completely leave out the plus 0n. However, I'm using it as a placeholder here to show that I am in fact including the term for b. And then we simply add 3 on the end as we are adding c. Now, for another example, you can pause the video here and try this for yourself if you like, or you could follow along with what I'm doing. Again, we need to find the first difference, which is going to be 13, 17, 21 and 25. Again, these are different, therefore this must lead to a quadratic sequence. So, the second difference is 4, 4 and 4. All the same, must be quadratic. Now, let's find a. 2a is our second difference, so here 2a is 4, meaning a equals 2. 3a plus b is our first difference, or the green 13. Therefore, we know that 3 times 2, because a is 2, plus b equals 13. 3 times 2 is 6. 13 take away 6 is 7, meaning b equals 7. Finally, a plus b plus c is that first term, in this case the 5. Therefore, we know that 2 plus 7 plus c equals 5. 2 add 7 is 9. 5 take away 9 is minus 4, leaving c as minus 4. Simply write this in this form an squared plus bn plus c. So we should get 2n squared plus 7n minus 4. Remember, if it is a negative value for a, b or c, switch the sign in front of it. Just make sure you do that, as that is a common mistake that people make.